We'll now continue our discussion of section 9.2 and continue with two additional examples for a parabola. Our first example says, given that the directrix of a parabola is the line y is equal to 2, that p is equal to -1, and that the parabola is symmetric with respect to the line x is equal to 2, find its standard form equation. So we're going to begin by plotting the information that we're given. So we're told that the directrix is the line y is equal to 2. So remember that a line that starts with the variable y is a horizontal line. So we're going to come up 2 tick marks on the x-axis, and we're going to draw that directrix. So this will be the line y is equal to 2. Now remember that this line, being that it's the directrix, is going to sit behind our parabola. And so if the directrix is there, we know that the parabola is either going to open up or the parabola is going to open down, so that the line of the directrix can sit behind the parabola. Now, the fact that the p is equal to -1 helps us narrow down whether this parabola opens up or down. Remember that if the p-value is negative, then that's going to indicate that the parabola opens towards a negative direction, and so it's going to open down. And so you want to first make that determination. So again, the position of the directrix is going to narrow it down to either up or down, and then the fact that it's negative indicates the parabola opens down. Now, the other thing that I know is that the p-value is the distance from the directrix to the vertex, and also from the vertex to the focus. So I know that the distance, I'm just going to jot this down, from vertex to focus is equal to 1. And I know that the distance from the directrix to the vertex is also equal to 1. That's what the p-value gives us. The other thing that we know is that the parabola is symmetric with respect to the line x is equal to 2. So let's think about where x is equal to 2 is. X is equal to 2 is going to be a vertical line at 2. So this is a line of symmetry for our parabola, which means that that line is going to cut our parabola in half. So think about that. If the red line is going to cut the parabola in half, then the red line has to go through the vertex of the parabola. So putting this information together, I know that my vertex has to lie along the red line. And I also know that my vertex is 1 unit away from the directrix. And so if my directrix is here, and I'm 1 unit away on the red line, then I've got to be here for my vertex. So my vertex is going to be the point 2, +1. And we've already said that the parabola is going to open down. Now I don't really know necessarily exactly how wide to make it, but I'm just doing a rough sketch here anyway. All right, so we have our vertex at 2, 1, and our focus then would sit 1 unit down further than that, so this would be the point 2, 0 for the focus. Now, once we have that picture sketched out and we have an idea of how the information that we're given plays out in that picture, we can go ahead and write our formula. So I'm going to go back to my formulas. Now, I know that it opens down, so I'm going to get the correct formula. It's vertically oriented, and so I know that my parabola should start with x minus h squared. So I'm going to take that back to my problem, and I'm going to jot that down. So x minus h squared is equal to 4p times y minus k. And we're now going to plug our values in. So remember the h and the k is your vertex, and it holds an opposite relationship. So if the x value in my vertex is 2, then I'm going to be putting in a minus 2 into that formula. So I've got x minus 2 squared. I know that my p-value is -1. And in the y parenthesis, I need it to be the opposite of a +1, so it's going to be y minus 1. And so cleaning this up just a little bit, we can't do much towards simplifying. We can make it x minus 2 squared is equal to -4 times y minus 1. And that will be the equation of our parabola. Now, our second example that we're going to look at is an application problem. So our application says that we have this telescope that has a very large reflecting lens. It says the parabola at the top is the top surface of a large cylinder of Pyrex glass, 200 inches in diameter. Along the outer rim, the cylinder is 26.8 inches thick, while at the center it is 23 inches thick. Where is the focus of the parabolic mirror located? So they're going to give us a picture on the next slide, which is good that we have a picture of what this looks like, but keep in mind that what we're being asked to find is the focus. All right, so let's take a look at our picture. We're going to see that we're going to locate the origin as the vertex of the parabola. And so we're going to assume that the parabola opens up, and that is shown in our photo. All right, so this is what we've got. We have our parabola here, this dotted in blue. The vertex is at 0, 0. We are told that the top surface is 200 inches in diameter. Okay, so that is how, I just want to explain this picture just a little bit. If I know that the glass is 200 inches in diameter, that is why we have a 100 here and a -100 here. So we've gone 100 inches to the right and 100 inches back to the left, and that makes the 200 inches in diameter that we have for the lens. All right, we also know back from the problem that at the center the lens is 23 inches thick. And so from the bottom point of the inside curve down is a distance of 23, which is why we have this -23 at the bottom. And we know that on the outside rim that it's 26.8. So in other words, from the top down is going to be 26.8. So I'm just going to go ahead and mark that so we can see it. And so the reason that they're coming up with this 3.8 is, remember, you've got 23 inches to the bottom of the curve, and then you would need an additional 3.8 to get to that 26.8, because I know that 23 plus 3.8 is going to give me 26.8. And so that's why we're coming up 3.8 on both edges. Now, since the parabola is centered at 0, 0, we know that our vertex, our h and our k values are going to be 0, 0, and we know that it opens up. So what they're doing now is they're taking the formula x minus h squared is equal to 4p y minus k, and they're putting a 0 in for the h and the k, which causes this formula to go to x squared is equal to 4p times y. So now all we need to do is determine what the p value is, and then we can determine the focus at the parabola. All right, so what do we know? We need to come up with an x and a y value that we can plug in. So I'm going to take one of these points. I think I'm going to use the positive one just because it'll be a little bit easier. And I'm going to put a 100 in for the x. And I'm going to put a 3.8 in for the y. So I'm just using this x and y value, which is going to allow me to come in and solve for the p. So I'm going to multiply the 4 times the 3.8. That's going to give me 15.2. And 100 squared is going to be 10,000. And then I'm going to divide both sides by 15.2. So that would tell me that P is going to be 657.9 inches. Okay, and so that is going to be my P value. And the book does go ahead and convert that to feet. So if in your homework problems they're asking for it in inches, we're done. If it asks for it in feet, you would need to divide that by 12, and you could come up with approximately 54.8 feet. And so remember that your focus is P units away from your vertex. So to come up with your focus, you would simply move up 55 feet. And so the answer to the question, where is the focus of the telescope, we could say that the focus is 55 feet up from the mirror.